guys, Miss Rizzy here. I miss seeing you. I am going to show you the lesson that goes with week 3, dependent events. So let's do a little bit of a review here. Okay, last week we did independent. Independent events is when one does not affect the other. One does not affect the other. Okay? This week we are talking about dependent probability. The difference is one event does affect the other. One event does affect the other. I'm going to make up a quick example here, and I'm going to show it to you both ways. Let's pretend I've got a bag with these marbles in it. 4 red, 5 blue, and 1 yellow. So I've got a bag that has 4 red, 5 blue, and 1 yellow marbles, okay? And I am going to replace the marble after I pick the first one. So I want to know what is the probability of getting a red, then a blue, with replacing. So I look at the red marble, I take it out of the bag, and then I put it back into the bag. That's what replacing means. Remember, you're always going to multiply probability of a red times probability of a blue. So the probability of getting a red the first time, there are 4 reds out of 10 marbles. So 4/10 times. What's the I look at the red marble, I put it back in the bag. I replaced it. Okay? What's the probability of getting a blue? Well, I have 5 blue marbles out of, there are still 10 marbles in the bag because I put the red marble back. So when I multiply this, I end up with 1/5. Okay? Now, I am going to do the same exact problem, but I am not replacing. So I'm going to, not replacing means you take that red marble and you put it on the counter, okay? So what is the probability of getting a red and then a blue? Well, we start with our marbles in our bag. Probability of a red is 4/10 times. Now, think about it. I took the red marble and it is now sitting on the counter. It's not in the bag. Okay, so now I only have 3 red marbles left in the bag. What's the probability that I get a blue? 5 out of, there are only 9 marbles left because I took the red marble out. This ends up being 2/9 when you multiply it, and you can use your calculator. This first one is called independent, because the first one does not affect the second one because there's the same amount of marbles. This is dependent because my second probability was affected by what happened on the first one. There were only 9 marbles left. That is the difference between dependent, one affects the other, and independent, one does not affect the other. But you still multiply the probabilities. All right, now we are on the actual notes in your Google Classroom. It says, example 1, we've got 4 oranges, 7 pears, and 5 apples. This is the example that we did last week, but last week we put the apple back. It says, Iggy selects a piece of fruit at random and eats it. He takes it, it's gone. And then Terrence selects a piece of fruit at random. What is the probability that 2 apples are being chosen? So, probability that the first one gets an apple times probability that the second one gets an apple. Well, how many apples are there? 5 apples out of, if I add this up, I get 16. 4 plus 5 plus 7 is 16. So 5/16 is the probability that the first guy gets his apple. Now, think about this. Iggy, he took his apple, he ate it, it's gone. How many apples are now left? 4. 4 apples. So Terrence, his probability of getting an apple, there are only 4 apples left out of only 15 pieces of fruit. Okay, because that first guy took the apple, it's gone. When you multiply these, you end up with 1/12. This is dependent because this second probability depends on what happened the first time. Okay, example 2. Mr. Grabner has a box of Annie Graham snacks for Jana. The box has 8 bags of chocolate, 4 bags of chocolate chip, and 8 bags of honey grams. I read that out of order, it doesn't matter. What is the probability that Mr. Grabner picked a bag for lunch, that is honey grams, and then Mrs. Grabner picked chocolate chip? So, probability of honey grams times probability of chocolate chip. Now, think about it. The first guy, Mr. Grabner, picks honey grams. Well, let's add this up. This is 20 total, okay? 20 total. He wants honey grams. So there's 8 out of 20. He packs his lunch. That bag is sitting in the refrigerator, okay? So honey grams goes down to 7. What is the probability that Mrs. Grabner can now pick chocolate chip? Well, there's still 4 chocolate chip because Mr. Grabner didn't take that, but there's only 19 bags left. So when you multiply this, use your calculator, you get 8 out of 95. Dependent. Mrs. Grabner's pick depends on Mr. Grabner's. Okay, let's look at example 3. This is dependent. Example 3. There are 18 blue socks and 24 black socks. Okay. What is the probability of randomly picking 2 black socks without replacing? You're not putting it back. Well, the total here, there's 42 socks. 18 plus 22 is 42. So you want the probability of getting a black times probability of getting a black. And remember, you're not putting it back. So how many black socks are there? 24 out of 42. That's the original pick. Now, you took one of the black socks out, so there's only 23 left. So, what's the probability of getting a black sock on the second pick? 23 out of, now there's only 41. Please use your calculators. You end up with 92 over 287. Again, that is dependent probability. Okay, last example. Example 4. We have 3 red shirts, 4 black, 2 green, and 3 yellow. Now, the first part says, find the probability of Maddie is packing for her trip. So think about this. When you pack for a trip, if I'm looking in my closet and I decide I want to take a green shirt, I'm going to take that shirt and I'm going to go put it in my suitcase. Okay? So Maddie is packing for a trip. Find the probability that she packs a black shirt and then a yellow. And remember, she's putting it in her suitcase. So how many shirts is this total? 11. That adds up to 11. So what's the probability of getting a black? 4 out of 11 times, what's the probability of getting a yellow? Now remember, she packed that in her suitcase. There's only 3 black shirts left. 3 out of, no, I want probability of yellow. There's 3 yellows out of only 10 shirts. And when you multiply this, what do I get? 2/5. So 6 over 55. Now, they changed the problem. It says, how does the probability change if she chooses a shirt and then replaces it? She puts it back in the closet. I guess she changed her mind. We want to know the probability of a red and then a red. Now, I'm going to put this back to where it was. There were, how many black shirts? 4 black. Okay, so probability of getting a red is 3 out of 11. Now, for whatever reason, Maddie decided she didn't want to pack that red shirt, so she puts it back in her closet. What's the probability that she gets another red? 3 out of 11. That ends up being 9 out of 121. Oh, you know what, guys? I added these wrong. That's 7, 8, 9, it's 12. Okay, so I'm a knucklehead. It's 12. So you would do the same thing except change the denominator to 12. So probability of getting a red times probability of getting a red is 3 out of 12 times 3 out of 12, which ends up being 1/16. The one that we had just done would have been 4 out of 12 times 3 out of 11. Ends up being 1/11. I'm sorry, I wasn't even looking at my numbers. All right. Hopefully that helps you guys understand this. Please let me know if you have any questions.